Welcome to Study Loop.
Once again, welcome to a new problem. This time we have a block and it's hanging from the ceiling. The mass of the block happens to be the mass of the block happens to be 0.8 kilograms. And then we also have a bullet that's been fired. The mass of the bullet, so we're going to call, just to distinguish it from the block, we're going to call it L. So the mass of the bullet, ml, is 0.012 kilograms. The initial velocity of the bullet is what we're looking for. That's what we want to find. But then we're given other pieces of information. For example, we're also given that the tension in this string happens, or cord happens to be 4.8 newtons. So this is what's happening before any collision between the block and the bullet. The other piece of information that we're given is that the length of this cord is 1.6 meters. So that's the information we're given. And the bullet is going to be fired. So the bullet is going to be fired. And the they're saying it's fired with a horizontal velocity v naught. So we're looking for v naught instead of using v initial. We're going to use v naught. That's the convention they want us to use. So when it's fired, this is how it looks like. Now the bullet is inside of the block, and so you have the total mass of the block and the bullet, which we're going to call it m total. Is going to be the sum of the mass of the bullet and the block. So that's 0.812 kilograms. That's m total. And then something else that happens is now you have a final velocity of the block and the bullet, and then you also have the weight of the block and the bullet, so mtg. We have a component of the weight, which is mtg cosine theta. This angle right here is theta. The height that we're dealing with, this height is 0.8 meters, and this other height is also 0.8 meters. Remember, if you can recall, the length length of the cord or the string is 1.6 meters. And so we can always say that theta this is 1.6. So we can always say that cosine of theta cosine of theta is 0.8 meters over 1.6 meters. And so theta is cosine inverse of 0.6 meters over 1.6 meters. And that gives us cosine inverse of 1/2. And so theta is 60 degrees. So that's part of the information that we're given. The other thing that's showing up in this problem is that now we have all the information. We have the tension. This is the tension in the string, and it's pointing upwards like that. We also have the centripetal force, which is helping the object to go that way, and this centripetal force is mt Vt final squared over L. That's the centripetal force. So this is the information we're given. In the next page, the first thing we'll do is to use the Newton's second law. Okay, so we're going to use Newton's second law, which says that the sum of the forces is equivalent to the mass times the acceleration. The sum of the forces happens to be, we have the tension, and mtg cosine theta is responsible for the centripetal force, in this case, squared over L. And in this case, we want to solve for this final velocity. So it means we multiply both sides by L over mt. This side also by L over mt. So we get the final velocity of the block, and the just as a quick recap, remember this is the mass of the block and the bullet. That's the total. So 0.012 kilograms plus 0.800 kilograms, and that gives you 0.812 kilograms. Remember, whenever you see this T, that's the total. So this T means the combined for both of them. So this gives us L over mt times the tension, G cosine theta, like that. And so we plug in those numbers. We'll see this one becomes square root. L is 1.6 meters over T. Total mass is 0.812 kilograms times the tension, 4.8 newtons, minus the total mass, 0.812 kilograms, times acceleration due to gravity, 9.8 meters per second, times cosine of 60 degrees. And then we get a velocity. So the final velocity for this system happens to be 1.272 meters per second. That's just the first part, or the first step, and then we'll use the conservation of energy. Okay, so according to the law of conservation, of energy, we get that the final kinetic energy of the system equals to the potential energy, okay, equals to the potential energy times the or not times, but plus the plus the initial kinetic energy. So actually, let's backtrack a little bit. This is initial. Sorry, this one is initial and this one is final. So the initial kinetic energy, equals to the final potential energy and the final kinetic energy. So it's split like that. So this is 1/2 mt, that's the total for the mass, the block and the bullet, times velocity total final, which we got right here. Okay, so that's what we're going to use, total final squared, equals to the potential energy, which is mt gh. Remember, h is this height right here, when it changes height from this position to that position. So that difference in height, that's the h, and then plus 1/2 mt. Uh, Actually, this is Vt initial. Yes, this one right here, this one right here should be the initial velocity. Um, yeah, so this is the initial velocity. We have this is the final. So this is the total velocity after the collision, and then this is the final that we had from before. So uh, so we had two velocities. So this is v total final. This should have been initial. So this one we should have called it initial. So we don't get any contradictions right there. So this is the initial velocity when they collide, and then this is the final velocity. When they're moving together. So this is yes. So that's initial. V t initial like that. So v t initial squared. Okay. So this is v t initial like that. So we're gonna solve for the final. The masses cancel out, and so we have Vt final being equivalent to the square root of 2gh plus Vt initial. And so when we plug in the numbers, we get 9.8 meters per second squared times 0.8. So we're going to get, so we have to plug in those numbers. Let's see. We plug in those numbers. What do we get? We're going to get, so it's two times, let's see. Let's see what's going to happen to this. So we're plugging in these numbers to compute uh, the results here. And so this one is 2.98 meters per second times 0.8 meters plus 1.272 meters per second, like that. 1.272 meters per second squared. So this was supposed to be squared, like that. And then when we simplify that, we get 4.159 meters per second. Okay, so we get meters per second like that. Um, um, so then 4 point, and then in the next page, we're gonna use conservation of momentum. Yes. So law of conservation of momentum, which says that the initial momentum of the system equals to the final momentum of the system. And now we're very close. So mass of a bullet times the initial velocity of bullet equals to the total mass times the final velocity. So V naught equals to mt Vt final over ml, and this becomes 0.812 kilograms times the final, which is 4.159 meters per second, all over the mass of the bullet, which is 0.012 kilograms. A lot of numbers going on here, so it's very easy to make a mistake just because you have so many numbers going on in this problem. But you just gotta be patient. 4.159 and then divide by 0.012, and that gives us 281. So V naught becomes equivalent to 200 and approximately 281.43 meters per second. Hope you enjoyed the problem. Feel free to ask any questions. Again, we had a system where a bullet was being fired on a block and it's pushing the block upwards. So we have an initial case. We have to find the initial velocity when it collides with the block. So this one, we should have called it initial. When it's rising up, just for purposes of convenience in computations. That's the total. And prior to the collision, the block um, and the bullet are separate, but then they combine. That's why we're calling this total mass. And then we do the computations to get this initial velocity when they collide, and then they keep on moving and they keep on rising upwards, and we're going to have a final velocity as they ride upwards. So that's the velocity we want to get. Then the purpose of that is to help us compute the momentum. Remember, the initial momentum and the final are the same because of law of conservation of momentum. Hope you enjoyed the problem. Feel free to ask any questions, and thanks for watching, and have a wonderful day. Okay, bye.